Hello everyone, this is Mr. Regener, and this is the Topic 6 Assessment Practice. So I'm going to be using my Envision math book here, and starting on page 259, we have 4 pages of the assessment practice. So just like some of my other videos, we want to use this video in the best way possible for you. So maybe you struggle with number 1, you'll want to watch number 1, but maybe you get number 2, you can skip that. And so hopefully you can follow along. So I'll write the numbers here on my paper. I'll start with number 1 and I'll circle them, so maybe it's easier to find them as you scroll through the video. So let's start off with number 1. It says, Mr. Dodd filled the gas tank on his lawnmower with 3 8/10 gallons of gas. He mowed his yard 10 times on the same tank of gas. He used the same amount of gas each time. How much gas did he use each time? Write an equation to show your work and explain how the decimal point moves. Well, a lot of these problems I would recommend reading them multiple times. So we know there's 3 8/10 gallons of gas, and he's mowing his yard 10 times on that amount of gas, right? So he used the same amount of gas each time. We're going to take this total, 3 8/10 gallons, and he's mowing 10 times. I'll say 10 mows. Sounds weird. 10 mows in 3.8 gallons. We want to figure out how much gas he's using in one mowing. So I'm going to take this 3.8 and divide it up into 10 parts. So I'm dividing it by 10. So 3.8 divided by 10. So I'm going to go ahead and set that up. Again, make sure you're setting it up correctly with your divisor divided by 10. Divisor always goes on the outside. I've got a decimal point in my dividend, so my rule is to move it on up. Once I've moved it up, then I can divide like normal. So 10 doesn't go into 3. I could put a 0 here or leave it blank. 10 does go into 38 3 times. 3 times 10 is 30. I'll subtract. I end up with 8. Now watch what I can do here with this decimal. I can add on a 0. I haven't changed. It's still the same as 3.8 gallons. Now it's 3.80. 3 8/10 is the same as 3 80/100. So I can bring that 0 down. 10 goes into 80. 8 times 10 is 80. Subtract, and I get that beautiful remainder of 0. So how much gas did he use each time? He used 38/100 gallons each mowing. And then it says explain how the decimal moves. Well, it moves by just moving up from your divisor into the quotient. So hopefully that helps you out for number 1. Hey, take a look at number 2. Now in number 2 we have Kimberly. It says Kimberly scored a total of 35 8/100 points in 4 events for her gymnastic competition. If she scored the same number of points in each event, how many points did she score in each? Write an equation to show your work. Well, we're going to take that 35 8/100 points, and we're going to divide it amongst the 4 competitions. So these are the points, and there were 4 competitions. So pretty simple there. So I'm just going to do the math here. So I have 35 8/100 divided by 4. Just like in number 1, I've got a decimal in my divisor. I'm just going to move it on up, bloop, right there into my quotient. Now, I've mentioned this before. It may help you to have some underlines here to know that there are 4 digits or 4 place values. That way we make sure that that decimal goes in the right spot. That's especially helpful if you're somebody that's maybe a little bit sloppier with your work. So, does 4 go into 3? No. I could put a 0 there. I could leave it blank. Either way. Does 4 go into 35? Of course it does. Let's see. 4 times 9, well, that's 36. 4 times 8, that's 32. So 8. Put my 32, subtract, I end up with 3. Bring down my 0. Does 4 go into 30? It sure does, 7 times. That would be 28. And again, I'm kind of going through the math here quickly on purpose, because it's a video. But we could always guess and check if we're not quite sure of some of these numbers. Does 4 go into 28? Yes, indeedy. It goes in 7 times. 7 times 4 is 28. And I get that beautiful remainder of 0. So my answer here is 8 77/100 points in each competition. There you have number 2. Let's move on. Take a look at number 3. Love questions like number 3 because this is that one grid, right? So we've got like one question, but it's really 4 questions in all. So I'm going to go ahead and answer all 4 of these questions, and I know that my answers are going to be one of these 4 here. So I don't know if in the video you can see this super well, but I'll write it down here on my page to make it a little bit easier. So the first one says 21 6/10 divided by 1 8/10. So I'm just going to do the math. Now here I've got a decimal in my divisor, so I know I want to move that over to the right as far as I can go. That's 1 space. Here's my copycat here in the dividend. I'm going to move that over 1 space because it wants to be just like the divisor. And then whoop, float it up to the top. Move it on up. Right now I've got 18 divided by 216. To make that look a little cleaner, I'm just going to rewrite it. I think that we'd all probably agree that looks a little bit nicer and easier to maybe deal with. So 18, does it go into 2? No. It doesn't go into 2. Does 18 go into 21? Yes, 1 time. That's 18. I'll subtract. 21 minus 18 will give me 3. I'll bring down my 6. 18 goes into 36 2 times. 2 times 18 is 36. And I get that beautiful remainder of 0. So number 3, my answer is 12. Or number 3. Number 3, the first one is 12, and there it is, 12. The next problem I see is 10 23/100 divided by 55/100. So there it is. We've got a decimal in our divisor. We want to move that over as far as it can go. In this case, it's 2 spaces. That means our copycat is going to move over 2 spaces. It does everything the divisor does. And then move that decimal up. Again, just because of my lines and it maybe looks confusing, maybe you're confused about maybe more than 1 decimal or something, I'm going to rewrite that. My divisor is 55, and I have 1023 as my dividend. Now it's just regular old-fashioned division. Does 55 go into 1? No. 10? No. 102? Yes. Now here's where it's tricky. You might think what goes in 2 times, but 2 times 55 would be 110. It actually goes in once. So again, guessing and checking might help you out there. We can borrow, of course. That becomes 12 minus 5, which is 7. 9 minus 5, which is 4. 0 minus nothing is 0. So 47 is less than 55, so I know I did that correctly. I'll bring down my 3. 55 goes into 473. It sure does. But to be honest with you guys, I have no idea how many times. I've got to guess and check. So my gut is telling me 4 times, and I don't know why. Because I don't think that's right. I'm going to go with maybe 6 times. I don't know. Again, I'm just taking a kind of wild stab here. 6 times 5 is 30. 6 times 5 is still 30, plus 3 is 330. It's a good area code, but it's a wrong answer. All right, I've got to jump that up a little bit. Let me go up to 8. 55 times 8. So 8 times 5 is 40. 8 times 5 is 40, plus 4 is 440. Ooh, pretty good, right? Now, do you think I could put another group of 55 in there? Probably not. So 8 is my answer there. That's 440. I'll subtract. 3 minus 0 is 3. 7 minus 4 is 3. And 4 minus 4 is 0. So I get 33, which is less than 55. Now here's the tricky part. We've got to add that decimal on and a 0. Haven't changed the value at all. But I add that 0. That allows me to keep on going. Right? So now 55, does it go into 330? Methinks so. And look, I already did the math here 6 times. So I'm going to put that decimal up top because we move it on up. Put my 6 here. 6 times 55 is 330. And I get a 0 remainder. So my answer for that one is 18 6/10. And it just so happens that's one of my answers on this list. 18 6/10. Take a look at the next one. 78 75/100 divided by 3 5/10. So let's do some math. Got to move my decimal over to the right 1 time because I can't move it more than once. Over here, the copycat just moves over 1 time and then it floats to the top. Again, you don't have to, but I like the idea of rewriting it. It makes it look a little bit cleaner for me. So now my divisor is 35 and I have 787 decimal 5. 787 5/10. I move that decimal up from the dividend up into the quotient. Now I divide. 35. Does it go into 7? No. Does it go into 78? Yes. In fact, 35, let me think about this. 35 times 2, that would be 70. And I don't think I can get better than that. So 2 times 35 is 70. Subtract, I get 8. I'll bring down my 7. Now, again, 70. If I try to fit another group of 35 in there, I'm going to be over. So I'm going to go 2 again. So that's still 70. And I get 17. Bring down my 5. 35 does go into 175. I just don't know how many times. So again, I'm going to take a wild guess. I'm going to check my answer. I'm going to do my checking maybe up here because I have a little more room. So I'm going to guess, oh gee, I don't know. I'm thinking like 3, and how many times 3 might go into 17. So I'm thinking maybe like 6. I'm going to guess 6, maybe. I don't know, I might be a little over. I'm going to guess 5. Let's go with 5. So 35, I convinced, you see how I did that? Convinced myself here in the video. 5 times 5 is 25, 5 times 3 is 15, plus 2 is 17. Look, I'm glad I convinced myself of that. Let's go with 5 here. 5 times 35, we've already figured out, is 175. We get that beautiful remainder of 0. So my answer there is 22 and 5/10, and there's 22 and 5/10 for that mark there. Notice you have to take your time on this. It's called long division for a reason, right? Next one, we've got 29 and 67/100 divided by 4 and 6/10. Necessary to move some decimals here in my divisor. I'm going to move that over. Same number of spaces, 1 space, 1 space, float it up to the top. Again, I'm going to rewrite it only because I like it to be clean. And I feel like that doesn't distract me from my math work that way. So now it's just regular old-fashioned division. 46 doesn't go into 2, doesn't go into 29, it does go into 296. And again, I don't know how many times, but I can think of 46 as being close to 50. And 50 goes into 300 6 times. So maybe 46 would go into 296 6 times. That's my thought process. Let me do the math and check it out here. 6 times 6 is 36. 6 times 4 is 24. Plus 3, 27. Get 276. Boy, I don't think I could put another 46 in there. So 6 is the way to go for that one. Ooh, I forgot to bring my decimal up there when I rewrote that. Sorry about that. 6 times 46 is 276. And then I subtract 6 minus 6 is 0. 9 minus 7 is 2. 2 minus 2 is nothing, so I get 20. I'll bring down my 7. 46 goes into 207 for sure. I just don't know how many times. Now I know 6 times was 276. I'm going to guess maybe like 4 times. And I'm going to check that. 4 times 6 is 24. 4 times 4 is 16, plus 2 is 18. I get 184. Again, I don't think I could fit another 46 in there without going over 207, so that is correct. Put my 4. We know that's, oops, we know it's 184. I'll subtract. 7 minus 4 is 3. I have to borrow here. That becomes 10 minus 8, which is 2. And 1 minus 1, which is nothing. So I get 23. Again, this is another one kind of like up here. We need to add that 0 on. Bring it down. And now we're thinking, how many times does 46 go into 230? Check this out. We know 4 was 184, and 6 was 276. I'm going to try right in the middle, smack dab in the middle, 46 times 5. 6 times 5 is 30. 5 times 4 is 20, plus 3 is 23. 230, 230. That's what I'm shooting for this whole time. So I'm going to put my 5 there above that 0 that I added. 5 times 46 is 230. We get an answer of, or a remainder of 0, and an answer of 6 and 45/100. Check it out, 6 and 45/100. Now guys, I don't want to fool you guys too much here, because check this out. There's 4 different problems for number 3. If I've found 3 of them, I know the 4th one, right? So maybe make it a little bit easier on yourself if you need to use that strategy. That is number 3. Let's move on to number 4. Number 4 says, it's at the bottom of my page. I've got my camera posted here, and I can't move it up. Anyway, what is the value of the missing exponent in the equation? So we have 80 and 5/10 divided by 10 to a certain power equals 805 thousandths. Well, we've got to think about this, right? We're dividing. So we know that decimal is going to move to the left because we're dividing. In this case, it's moving 1 space, 2 spaces, right? So if it's moving 2 spaces over, every time we multiply we're divided by 10, we're just moving our decimal to the left or to the right. In this case, we're dividing, so it goes to the left. If I divide by just 10 to the first power, it goes 1 space. 10 to the second power, 2 spaces. 10 to the third power, 3 spaces, right? And so on and so on. So my answer for number 4 is pretty clearly going to be B. That's 10 to the second power because it's moving 2 spaces. Take a look at number 5. That was a quick one, right? Number 5, the chef at a restaurant bought 37 pounds of salad for $46.25. How much did she pay for each pound of salad? Well, guys, it's multiple choice, but I kind of have to do the math here. So again, it's 37 pounds, and it was $46.25. I'm going to write that out just as a regular decimal, 46 and 25 hundredths. And I'm going to divide that by the number of pounds. That was 37 pounds. I'm going to figure out how many times 37 can go into this big number, or how many times I can take this number and split it up into 37 parts. That's going to be my quotient. I've got a decimal in the dividend, move that up, and I'm ready to rock. 37 doesn't go into 4, but it does go into 46 one time. That's 37. I'll subtract. Gotta borrow. 16 minus 17 is 9. Bring down my 2. 37 goes into 92 for sure. But boy, I'm not quite sure how many times. Got myself thinking 3 because 3 times 3 is 9. But I know it's got to be less than that because it's going to be over. So I'll do 37 times 2 just to check my work here. I've got the math going. 14. 2 times 3 is 6 plus 1 is 7. I get 74. So I'll put my 2. 2 times 37 is 74. I'll subtract. Gotta borrow. 12 minus 14 is 8. 8 minus 7 is 1. Notice I did it right because this number is smaller than my dividend. Or my divisor, I'm sorry. 18 smaller than 37. Bring down my 5. 37 goes into 185. I just don't know how many times. So again, I'm going to guess and check. So I'm going to go 37 times, just a random guess here. I'm going to go maybe 6 because I think 3 times 6 is 18, right? We're going to try it out. We're going to see what happens. You guys think I'm all prepared for this video? I'm just doing it off the cuff here. 7 times 6 is 42, and 6 times 3 is 18. 18 plus 4 is 22. Ooh, man, I had an instinct there. My gut was saying, don't go 6. Don't do it. But I did. I had to check it. I'm going to go 5 now, and I'm pretty sure I know what's going to happen. 5 times 7 is 35. 5 times 3 is 15, plus 3 is 18. I get 185. Look at that, the golden number. So I'm going to go ahead and put in my 5 here. 5 times 37, I did the math already, is 185, and I get that beautiful remainder of 0. That means then for this one, how much did she pay per pound? It's $1.25 per pound. If we look at our options, that has to be letter B. So I guess I could put letter B there also. There it is. Let's move on to number 6. Number 6 says, Kathleen spent $231 on concert tickets for herself and 11 friends. Each ticket costs the same amount. So 2 parts. Letter A, estimate the cost of the tickets. Letter B, find the exact cost. Well, couple things on this. First, you've got Kathleen and 11 friends. So think, how many people is this being split up between? Kathleen and 11 friends. That means there's 12 friends altogether. Right? And there's $231 that they spent on the tickets. We're going to take $231 and divide it by 12. But if we're estimating, there's a lot of routes we could take here. We want to come up with maybe complementary numbers. We want to come up with numbers that make sense. I think if I have 12 as my divisor, a number that's really close to 231 that would go really well with 12 is maybe 240, because 12 and 24 are complementary. So I might estimate it that way, right? So that kind of is our answer for letter A. But again, your estimate could be different. It kind of depends on the way that you're thinking. But I think that would make the most sense to estimate that as 240 divided by 12. Super easy because 12 goes into 24 2 times. That's 24. I'll bring down my 0. That's 0. That means it's $20 estimated. That's my estimate. Now let's do the real math. So I'm going to take 12 as my divisor, $231, and I'm really just dividing. So 12 doesn't go into 2, It does go into 23, but only once, right? Twice would give us 224. So I'm going to subtract. 3 minus 2 is 1. 2 minus 1 is 1. Bring down my 1. 12 goes into 111. Well, I got to think about this one now. I'm going to guess maybe 9 times, right? If you know your 12 facts, this is probably a lot easier. But I'm going to show my work here. 12 times 9. 9 times 2 is 18. 9 times 1 is 9, plus 1 is 10. That's 108. So put my 9 here. 108. Subtract. Borrow. 11 minus 8 gives me 3. 0 minus 0, 1 minus 1. I get 3 as a remainder, but wait. Remember, I can add on that decimal and that 0. Bring the decimal up. Bring my 0 down. 12 goes into 30 2 times. That's 24. Subtract, I get a 6. Add another 0, bring it down. 12 goes into 60. Aha, some of you are like, now this is making sense. 5 times 12 is 60. Get that beautiful remainder. So the actual cost is going to be $19.25 each, because there's 12 people going, $231, $19.25 each. Our estimate of 20 shows us that that is a reasonable answer. Let's move on. Take a look at number 7. Number 7 says select all of the following equations that are true when 12 and 5/10 is used. Use number sense to help. Well, I don't mind if I do. So I want to make sure I fill in the blanks here. So I'm going to go ahead and kind of solve all of them. Some of them are maybe more obvious than others. So if you got a question like this on your test, I'm hoping that you could use some of your math logic to help yourself out. So I'm going to plug in 12, oops, I can't even write it out. 12, let's see, that's 12 and 5/10 divided by 10. Look, it's just going to set up like a division problem. It says it's going to equal 1 and 25/100, but let me just check this out. So I'm going to bring my decimal up. Bloop, there it is. 10 goes into 12 one time. That's 10. 10 goes into 25 2 times. That's 20. Add that 0 on. 10 goes into 200. What? Wait a minute. Look at that. I messed up in the video. I don't know what I was kind of getting a step ahead of myself here. I brought this down. I had 2, brought down the 5. 10 went into 25 2 times. That was 20. Then I would subtract 25 minus 20 to get 5 and bring down my 0. 10 goes into 50 5 times. There we go. Now I'm back on track. So my answer there was 125. And look, that's what I was looking for. 1 and 25/100. So I would check that one for sure. The next one, it says we're going to take 12 and 5/10 divided by 1. And it says it's going to equal 1 and 25/100. Well, guys, this is going to be divided by 1. It's going to be the same exact thing. I'm not even going to do the math there and show you, so we know that one can't work out. Look at this. Very similar. 12 and 5/10 divided by 1 is 12 and 5/10. Of course, yeah, we just figured that one out. So I can check that third one. This one says 12 and 5/10 divided by 100 equals 1 and 25/100. Well, again, I could do the math here if I really even need to, right? It's not going to equal 1 and 25/100 because 100 is going to go into 125 one time. That's 1/10. It's got to be a number that's smaller than that, so no way for that one. And then this one, look, it says it starts with 1/10. I think they're on the right path here. Let me finish this problem off and see where it goes. I'll add the 0 and bring it down because I had a remainder that was not 0. 100 goes into 250 2 times. That's 200. I end up with 50 as a remainder. Add another 0, bring it down. 100 goes into 500 5 times. Some of you kind of guessed where that was going. We end up with 125 thousandths. 125 thousandths. I could check that last one. That's number 7. Let me turn the page now. Whew, we are into this video, and again, I do hope that you are skipping around to use the video in a way that's going to help you most. Here's number 8. Which division problem does the model test made represent? Well, look, they've grouped together 3 groups of 10, 20, 30, 40, 54. 10 groups of 54. So we're thinking of the division problem here, right? If you look at our options, they have 1 and 35/100 divided by 3. they have 1 and 62 hundredths divided by 3. So we got to think, okay, what is the model showing? So we've already said, if you look at these three groups, again, divided by 3, they're all divided by 3. We have groups of 54, right? 54 hundredths. They're all divided by 3. This one says 54 hundredths. This one says 54 hundredths. So just kind of process of elimination, we could figure that out. But now let's add up all of them. We have 50, 100, 150. Then there's 4, 4, and 4. So that all together is 150 plus 12. Sorry, I thought I was going to sneeze there. All right, 150 plus 12, that's 162, or 1 and 62 hundredths. So my answer here for number 8 is D. Hopefully that makes sense for you. Let's move on. Take a look at number 9. Number 9 says, if 8 ounces of canned pumpkin has 82 calories, how many calories are in 1 ounce? Use your answer to find how many calories are in 6 ounces of pumpkin. Ooh, so there's like 2 parts here, right? So 8 ounces of canned pumpkin, there's 82 calories. We want to figure out then how many ounces, or how many calories are in 1 ounce. So I'm going to take my 82 and divide by 8. So 8 goes into 8 one time. That's 0. Bring down my 2. 8 goes into 2. Well, it doesn't. It goes in 0 times. And look, I've got this remainder. 0 times 8 is 0. Still have 2. I need to add a decimal. Bring that decimal up. Add a 0. Haven't changed the number of calories. Still 82. But now it's 82 and 0 tenths. That allows me to bring this down. 8 goes into 20 2 times. That's 16. Subtract, I get 4. Add another 0. Bring it down. 8 goes into 40 5 times. And that would be 40 with a beautiful remainder of 0. So my answer here is that each single calorie has each ounce has 10 and 25 hundredths calories. So 10 and 25 hundredths calories per 1 ounce. So how many calories are in 6 ounces? Let me just take this and multiply it times 6. That's going to tell me how many are in 6 ounces. So 6 times 5 is 30. 6 times 2 is 12. Plus 3 is 15. Drop that decimal down. Oops, I'm sorry. We can do that later, but we can do it now. 6 times 0 is 0. Plus 1 is 1. 6 times 1 is 6. And again, 2 decimal spaces. So 2 decimal spaces. We end up with 61 and 5 tenths calories per 6 ounces. So there you go. Moving on to number 10. Number 10 says use the equation 1 and 6 tenths divided by n equals 0 and 16 thousandths. What value of n makes the equation true? Write your answer using an exponent. Well, again, look, all we're doing is we're taking 1.6, and it's like that decimal has moved over 2 times to the left. So we know we're dividing, right? We're dividing by a power of 10, and since there were 2 moves, n has to equal 10 to the second power. Letter B says, explain how you know your answer is correct, because if I have a power of 10, in this case a power to the second power, I'm going to move it over 2 times. If I'm dividing, I'm going to the left. This is stuff we've been working on for a little while, so hopefully that one comes kind of quickly for you. Take a look at number 11. Number 11 says, Eileen bought 8 roses for $45.50. Which is the best way to estimate the cost of 1 rose? I don't need to write much down here. This is more of a thought question, right? But I could write down what I would normally do. I would normally take the price and divide by 8. It's not asking me for the real answer. It wants to know the best estimate. So let me look at some of these numbers here. I'm trying to find compatible numbers. In the first one, 45 divided by 5, they took 8, brought it down to 5, 45 and 50 cents, down to 45. Kind of makes sense, right? We've got 48 and 8, 45 and 10, 40 and 8. Try to think of some compatible numbers that you would want to use. We can also think to ourselves, are they accurate, right? For example, 5 times 9 is 45. 8 times 6 is 48. 10 times 45 cents 45 hundredths is 45 and, or is not 45, and 8 times 50 hundredths would not be 40. So we can eliminate some of them, like C and D, for example, are incorrect answers. So let's just focus on A and B. Would it make the most sense to take 45 divided by 5 or 48 divided by 8? In the one example, we're changing 8 to 5. In the other, we're keeping it the same. In the one where we change the 8 to the 5, we take 45, 50 cents and make it 45. In letter B, we're taking 45 and 50 cents and we're bumping it up to 48. So would it make the most sense to keep the divisor as being 8, or do we want to change the divisor, or would it make more sense to change the dividend? In this problem, as you look at it, it would probably make the most sense to keep that divisor as 8 flowers. So letter B is our best estimate. Again, because letter B is going to give us the most accurate. Now, another thing we could do on number 11 is we could actually solve it. If we solved it, we would be able to come up with the answer that's closest to our answer, and the one that's closest to our answer would be 6. Let's move on and take a look at number 12. Boy, this looks scary, right? There's 3 parts to it, but it's really just one problem. Toby's faucet dripped a total of 1 and 92 hundredths liters of water in 24 hours. The faucet dripped the same amount each hour. So, letter A, estimate how many liters the faucet would drip. So we know we're going to take 1 and 92 hundredths and divide by 24 to figure out how much it's dripping in 1 hour, right? For my estimate, again, just like I said for the other one, there's a lot of ways we could go with this, but it may make sense to try to come up with some compatible numbers. So maybe we're going to take 1 and 92 hundredths and come up with, like, let's say 1 and 8 tenths, 24 and 1 or 18, right? We're thinking of those as maybe compatible because 6 goes into both of them. That might work out pretty well. There's other ways as well, but that might be one that would be maybe easiest. Letter B, find the exact amount. Well, that's what we're going to do now. So I'm going to bring that decimal up, move it on up. 24 doesn't go into 1, doesn't go into 19. It does go into 192, but I just don't know how many times. So I could put in my zeros here. Something's going to go above that too. I'm going to have to do some guessing and checking. Now, 24 is close to 25, and 25 would go into 200 8 times. So I'm going to guess maybe 8, but I think I know I'm going to be over. I'm going to do it anyway, though, just to show you. So 8 times 4 is 32. You see that? I tried to write a 3 and a 2 all together there. That was crazy. 8 times 2 is 16, plus 3 is 19. I get 192. I'm so glad I followed my gut and went with 8 there. Look at that. 8, I get 192. Even though I can't write it, I get a 0 remainder. That means it's dripping 8 hundredths liters. It is, right? Oops, liters per hour. There you go. I kind of got sloppy there at the end. Letter C, compare your estimate to your answer. Well, again, depending on what your estimate is, I'm going to go ahead and go with my answer from before and say 24 was my divisor. And I think I said I'd use 1 and 8 tenths, right? So for this, I know I'd bring my decimal up. I know I'd have a 0 here and a 0 there. I'd add a 0 here. 24 goes into 180. Let me think about this. I'm going to say probably like 7 times. And I'll check that because I'm not super confident. 24 times 7 is, 7 times 4 is 28. And 7 times 2 is 14, plus 2 is 16. I get 168. I couldn't fit another group in there, so I'll go with 7 here. 7 times 24, again, I did the math, 168. I'll subtract. Gotta borrow. That becomes 7. That becomes 10. 10 minus 2 is, or 10 minus 8 is 2. 7 minus 6 is 1. 1 minus 1 is 0. I'll add another 0 on, bring it down. 24 goes into 120. I think probably 5. Let's check that out. 24 times 5. 5 times 4 is 20. Yep, I think I was right. 5 times 2 is 10, plus 2 is 120. There you go. So it is 5 times 24 is 120. I'm subtracting it 0. So my estimate here was that it would be 75 thousandths liters per hour, My actual answer is 8/10 or 8/100. I can compare that for letter C. Let's move on and take a look now at number 13. Again, I hope you're using the video wisely to cover the questions that you need to look at to help yourself out. Number 13, again, there's 4 different problems, so I'm going to solve them all. Actually, you know what? I'm going to do this one kind of mentally for you guys, because look, 7/800 divided by 10. If I'm dividing by 10, I'm just moving that decimal over to the left 1 time. So look, here's 0.078, 78 thousandths. That one should be my answer. I'm going to try to zoom in if I can. Maybe you can see that a little better. There it is. This one, it says divided by 10 to the 3rd power. That means I'm going to move my decimal over 3 times. With a number like 7,080, moving it over 3 times means that I'm going to end up with 7 and really 8/100, right? Because I don't need that extra 0 on there. In this one, I have 70 and 8/10. I'm going to move it over 2 times. That ends up with 708 thousandths. And that's one of our answers there, right there. And then the next one, we had 780. We're going to divide by 10 to the 3rd power, move it to the left 3 times. I end up with 78/100. Again, I don't need that 0 on the end. So that was kind of a quick one, actually. I'm glad that one hopefully made sense. Let's take a look at number 14. Diego is making a large mural. He draws a hexagon with a perimeter of 10 and 5/10 meters. Each side of the hexagon is the same length. Look, each one is the same length. We don't know what it is. That's a question mark. So it says, how many meters long is each side of Diego's hexagon? Well, check it out. The whole thing is 10 and 5/10 meters. That means this plus that, plus that, plus that, plus that, plus that is 10 and 5/10 meters. Now a hexagon, look, has 1, 2, 3, 4, 5, 6 sides. So we just take that total perimeter and divide by the number of sides, 6 sides. Move our decimal up. Bloop, there it is. 6 doesn't go into 1. It goes into 10 one time. That's 6. I'm subtracting it 4. Bring down my 5. 6 goes into 45 9 times. 9 times 6 is 45. No, it's not. Oh, the lovely errors. What am I thinking here? 6 times 7 would be the correct answer. Let's put the 7 in there. That was a 7 the whole time. I don't know what you're talking about. I'll deny anything you say. 7 times 6 is actually 42. I end up with 3. I need to add a 0 and keep going because I don't have a 0 remainder. 6 goes into 30. Whew, now I'm in good shape. I've got a 5. Get my beautiful remainder. That means each side is 1 and 75/100 meters. Letter B says the total cost of the supplies to paint the mural is $38.70. Diego and 9 friends divide the total cost evenly. How much does each person pay? So this is like a totally separate problem for number 14. I'm going to call it 14B because it really is a different problem. I just wrote on my clock with a Sharpie. Oh, I'm very upset with myself. Anyway, it's $38.70. Again, it's Diego and 9 friends. That means there's 10 friends all together. So I'm going to take that total cost and divide it by 10. So 10 doesn't go into 3. It goes into 38 3 times. That's 30. That's 8 remaining. Bring down my 7. 10 goes into 87 8 times. That's 80. I'm rethinking my paper selection here. I should have used a new sheet. That's 7. I'll bring down my 0. 10 goes into 70 7 times. We know that would be 70 with a 0 remainder. So that means it costs $3.87 for each person. There it is. Let me move this back up. Okay. That is number 14. Let's move on to number 15. Number 15. These ones can be so tricky sometimes. It says select all of the following equations that are true when 40 and 3/10 is used. This one again looks tricky, but again I'm just going to write out 40 and 3/10, and I'm going to kind of use this and talk it through. If we divide that by 10 to the 1st power, I'm moving that decimal over. That would be 4 and 3/100, not 403. Can't be the first one. Here it is. If I divide it by 10 to the second power, 2 times over, that would be 403 thousandths, and that's what that one is. I would check that option. The next one, divide by 10 to the 0 power, that means I don't move it at all. It would stay the same, and I'd check that one as well. Divide by 10 to the third power, move over 1, 2, 3 times, fill in a 0. That would be 0.0403, and it's not definitely that one. Can't check it. The next one, divide by 10 to the second power, move it over 2 times. I would not have 4.03, I'd have 0.403. So number 15, hopefully, that one helps you for that one. Hey, check out number 16, Lou's Diner. Lou's Diner spent $12.80 on 8 pounds of potatoes. What was the cost of 1 pound of potato? Guys, I hope we're getting used to these questions, right? It's all good practice. $12.80 divided by 8 because there's 8 pounds of potatoes. 8 doesn't go into 1, it goes into 12 one time. That's 8. I'll subtract. I'll end up with 4. Bring down my 8. 8 goes into 48. Oops. 6 times. Should have brought that decimal up and I didn't until now. There it is. 6 times 8 is 48. Get a remainder of 0. Bring down my 0. 8 goes into 0 0 times. Remainder of 0. So that means it costs $1.60 per pound. The second part of it here says, what would be the total cost if the cost per pound remained the same and the diner bought 7 pounds? Okay, well, no problem. I'll just take $1.60 and multiply that by 7. 7 times 0 is 0. 7 times 6 is 42. 7 times 1 is 7 plus 4. That would be 11. And then I have 1, 2 moves, 1, 2 moves. That means it's $11. Why am I having such a hard time writing these numbers? This is supposed to be $11.20. And there you have it for number 16. Number 17, here it is. If you can see it. It says, how many quarters are there in $30? Well, again, this one might be kind of a logical think it through one, but it says solve the equation 30 divided by 25 hundredths, because that's 25 hundredths is 25 cents, right? So we're going to do that. 30 divided by 25 hundredths. Okay, this division problem is going to help me answer that question. I'll move my decimal over 2 times because I can't move it more, which means I add a decimal here and move it over 2 times. Add my zeros and bring that decimal up. Again, if we choose, it may help us out to rewrite this just so that it looks super nice. Of course, you can't see it. That's not good. There it is. All right, 25 doesn't go into 30. Doesn't go into 3. It goes into 30 one time. That's 25. That's a 5. Bring down my 0. 25 goes into 50 2 times. That is 50. Get a 0 remainder. Bring down my 0. 25 goes into 0 0 times. Still a remainder of 0. That means my answer is it goes in 120 times. There's 120 quarters, or letter C, for number 17. Let's move on and take a look at number 18. These bottom questions are always hard to get on my video. Here it is. When solving 6 1/10 divided by 2 to the second power, how is the decimal point moved? Well, again, we know we're dividing by a power of 10. That exponent is 2, so it moves to the left, division to the left, left 2 times. So this is kind of a silly one to even write down, but I'm going to. This would be 2 places to the left, letter D. Now, if we aren't sure about that, we could always divide it, right? We could always set it up 10 to the second power, right? Put in our numbers and divide if we need to do that. Let's move on now. Take a look at number 19. Guys, we're on our last page here. I don't know if you noticed this. And we're only 45 minutes into this video. It's crazy. Here's number 19. A group of 5 friends bought a bag of grapes to share equally. If the bag of grapes weighs $11.25 pounds, how much is each person's share? Let me stop there and answer that part of it. So 11.25 pounds divided up by 5 friends. Bring my decimal up. 5 doesn't go into 11, but it doesn't go into 1, but it goes into 11 2 times. That would be 10. Subtract to get 1. Bring down my 2. 5 goes into 12. 2 times. That would be 10. Bring down my 2. Bring down the 5. 5 goes into 25 5 times. That is 25. That's a remainder of 0. That means each friend is going to get 2 2/25 pounds each. So, the second part, how many friends could share the grapes if each person's share was 1 2/25 pounds? Write an equation to model your work. All right, so for this one, we'd have to figure out then if it's each person's share is 1 2/25 pounds. We're going to take the total, 11 2/25, and divide that by 1 2/25. Our quotient then is going to be how many friends. So it's kind of funny because here it was how many friends is our divisor, and the quotient was the portion. Now the divisor is the portion, and our quotient is going to be the friends. Again, it's kind of messing with the numbers, playing with the numbers. So here I've got to move my divisor, or the decimal in the divisor, over 2 times. The copycat moves over 2 times, and there it is. I can rewrite this to make it look cleaner. Since I'm kind of in the habit of doing it, I'm going to keep it up. There is a decimal here which would eventually move up. So I don't think we're going to have a decimal answer, but we'll find out. 125 doesn't go into 1, doesn't go into 11. It doesn't even go into 112, but it does go into 1,125. So I need to think about what my guess could be for this one. I did 10. Obviously, that's going to be really close. I'm going to try out 9. 125 times 9. 9 times 5 is 45. 9 times 2 is 18, plus 4 is 22. 9 times 1 is 9, plus 2 is 11. Look at that. Amazing. So I put my 9 here, did the math already. We know we're going to get that 0 remainder. That means that 9 friends can share the grapes if our portion is 1 2/25. Let's move on. Take a look at number 20. Number 20 says, when dividing 560 9/10 by 100, how should the decimal point be moved? Check it out. 100 is the same as saying 10 to the second power, right? Whenever we divide, we go to the left. If we're moving to the left, and this 100 is really 10 to the second power, that exponent hopefully helps you remember how many times to move. So 560.9 divided by 10 to the second power, that means we're going to move that decimal to the left 2 times and come up with 5 609,000. Again, we can kind of explain that here in number 20. For number 21, here it is. June says that there should be a decimal point in the quotient below after the 4. Is she correct? Use number sense to explain your answer. So I'm going to go ahead and write this one out here. She took this. We're going to divide that by 5 2/10. She says there should be a decimal after the 4. So in other words, it should say 84 5/10. Look, if I move this decimal over, 1 space, move this decimal over 1 space, float that up to the top, that means I'm going to have 1, 2, 3, 4 spaces here. But my answer is only 3 digits. That's because 52 doesn't go into 4. It doesn't go into 43. It does go into 490 or 439. My first number here is going to be in the ones place, right? That 8 is going to be here. The 4 is going to be here. And the 5 is going to be here. So should the decimal be after the 4? No, it actually should be before the 4, right? They didn't put the decimal in here. It should be after the 8 and before the 4. We did that because we kind of set it up. We didn't really do the math. We just knew the first place value, the first number is going to be in the ones place value after we move those decimals around. Let's move on. Let's take a look at number 22. There it is. 3 coworkers decided to buy fruit to share at lunchtime. Antonio spent $1.47 on bananas. Laura spent $2.88 on apples. Suzanne spent $2.85 on oranges. Complete the bar diagram to find out how much they spent in all. Now there's a couple of ways we can do this, right? We can use the bar diagram, or we can really just add the numbers together. We had $1.47 for Antonio. Laura had $2.88. And Suzanne had $2.85. Now, a couple ways we could add these up. I could add them just one at a time. I'm going to attempt this. This is scary stuff. But I'm going to try to add all three together all at once. Here we go. 8 plus 7, that's 15, plus 5, that's 20. 8 plus 8 is 16, plus 4 is 20, plus 2 is 22. Bring my decimal down, because I'm adding. They're lined up. Drop it down like a bowling ball, crashing through the floor. 2 plus 1 is 3, plus 2 is 5, plus 2 is 7. That means they spent $7.20. Now, if I had to use this for the bananas, I'd put $1.47. For the apples, I would put $2.88. And for the oranges, I'd put $2.85. Right? We don't need the bar diagram if we can just add them. For letter B, they evenly divide the cost of the three types of fruit. How much did each person pay? And complete the bar diagram to help you. So we're taking the total cost, which is, again, $7.20. We're going to split that up into three different groups, right? So we're just taking $7.20, dividing it by 3, because there's 3 people. So 3 goes into 7 2 times. Bring my decimal up. I should have done that. 2 times 3 is 6. Subtract to get 1. Bring down my 2. 3 goes into 12. 4 times 3 times 4 is 12. Subtract to get a 0. Bring down my 0. 3 goes into 0 0 times. Still a remainder of 0. That means each person would contribute $2.40. Letter C. Oh man, Laura, why would you do this to us? Laura bought 2.1 pounds of apples. If the price per pound of apples is greater or less than $1, how can you tell? What? Okay. This is crazy stuff. So, we got to look back at Laura. Laura spent $2.88. I'm going to bring out a brand new page for this because I want to have room to do it. It was $2.88 for Laura's apples. It says if she bought 2 1/10 pounds of apples, is the price per pound of apples greater or less than $1? We really could figure this out with a division problem, right? We have 2 1/10 as our divisor now and the cost of the apples. I'm going to move that over, copycat, bring it up. Now I really have 21 as my divisor and 28 8/10 with the decimal moved up into the quotient. 21 goes into 28 one time. I get a 7. Bring down my 8. 21 goes into 78. I've got to think this one through. But look, I don't have to, really. Right? It says, is it greater or less than? Well, I could solve it, right? But I automatically know it's got to be more because I have a remainder here that's not 0. So I have a 1 here, and I'm going to keep on going and add that on. This is crazy, but I'm not actually going to solve that problem. I'm just going to say I know for sure it's got to be more than $1 per pound because I have $1 here and I don't have a 0 remainder. It's got to be more. Guys, that was a very, very, very long video. If you made it this far, congratulations. I feel like I should give you a candy bar or something, but I'm not going to because the true gift is the fact that you have now prepared yourself for the Chapter 6 test, and I think that is better than a candy bar. Have a great day. Good luck on your test.